Welcome to Miss Suman's SG classes. Our today's topic is how to calculate valency. As you can see, I have mentioned here Z is equal to 1 to 20. Z represents atomic number. So we're going to talk about atomic number from 1 to 20. Not all the elements can be covered in one video. So we picked up from 1 to 20. Also, when we learn the elements and the symbols, we initially say that we need to know about atomic number from 1 to 20, and eventually we will go forward and learn the entire periodic table. So before we learn how to calculate the valency, we need to talk about three things here. The very first thing is the number of shells and the types of shells. The second thing is the valence shell. What does the valence shell means? And the third thing is valence electrons. So once we discover these three facts, that is when we will start talking about the formula to calculate valency. Let's get started. So here we will talk about four shells: K, L, M, N. Shell K can accommodate maximum of 2 electrons. So it is basically the capacity. It is not our choice that what we want. It is the capacity of this shell. Shell K can only have 2 electrons. It cannot have more than 2 electrons. Similarly, L can have 8, M can have 8, and N can have 18 electrons. I am sure you guys by now you know what are these magic numbers: 288, 18, 18, 32. In my previous video, we have talked about this, from where do we get these magic numbers. If you do not have the idea, I would highly recommend to go back and watch my video on Introduction to the Periodic Table and understand the concept that from where do we get these magic numbers. So let's talk about all these shells. So let's take an example of nitrogen. If I talk about nitrogen, the atomic number for nitrogen is 7. So the first thing we will do here is we will talk about the general electronic configuration. When we talk about the general electronic configuration, let's talk about the first shell. The first shell can accommodate 2 electrons. We are good. Now you all know 7 minus 2 is 5. The second shell can accommodate 8 electrons, but the nitrogen has only 5 more electrons left. This number 2 plus 5 should always be equal to the number of electrons present in that element. For example, by mistake, we cannot write this as the electronic configuration for nitrogen. Why? 2 plus 6 is equal to 8. While the number of electrons in nitrogen, you can very well see, are 7. So it is not possible. So the general electronic configuration of nitrogen is 2, 5. Let's take one more example. Ne. You all know the element Ne is neon. The symbol for neon is Ne. It is a inert group member. What is the atomic number for neon? That is 10. What will be the configuration? The first shell will have 2 electrons. The second shell will have 8 electrons. Do we need to send more electrons to the third shell? Let's check. 2 plus 8 is equal to 10, and there are 10 electrons. So it means neon will have the general electronic configuration of 2, 8. Let's talk about aluminium, the third and the final example here. Z equals to 13. So the general electronic configuration will be 2, 8. 2 plus 8 equals to 10. And how many electrons do we want? 13. So it means the third shell will have 3 electrons. 2, 8, 3. So this will be the general electronic configuration for aluminium. Here we have talked about nitrogen, neon, and aluminium. At this point, I would highly recommend to pause the video here and see all the atoms with atomic number 1 to 20 and write the general electronic configuration in the same way I have written here. Let's talk about the valence shells. What is a valence shell? As the name itself suggests, valence. Valence means last. Valence means last. Last shell. So if you look here, there are 2 electrons in K and 5 electrons in L shell. So how do we see a nucleus? This is the nucleus of an atom. Then this is how we have shells. So this is the K shell, this is the L shell. So what will be our valence shell? The valence shell will be the last shell, that is L shell. So in the case of nitrogen, L shell is the valence shell. Now let's talk about valence electrons. For nitrogen, there are 5 electrons in the valence shell. So we will say 5 valence electrons. In the case of aluminium, K, L, M. M is the valence shell, while 3 are the valence electrons. I am very sure now you guys have a pretty good understanding about how to write the general electronic configuration and how to figure out the valence shell and the valence electrons. These are very basic things, but we need to make sure that these facts are completely understood by us. There should not be a single doubt in the mind that what is a valence shell or what are the valence electrons. Also, the last thing I would like to talk here is about the octet rule. Before we go forward and start figuring out our valencies, we need to talk about the octet rule. So the octet rule states that the valence shell should have 8 electrons. Oct, you all know oct means 8. So the valence shell should have 8 electrons. Every atom, every element tries and satisfies this rule. If the element has to lose some electrons to get it done, it will try and lose electrons and form an ionic bond. If sharing is possible, it will try and go forward and do some sharing in order to fill the valence shell up to the capacity of at least 8. Octet rule. For every atom or element to be stable, the valence shell should have 8 electrons. Very good. Let's get started and take a look at the elements from 1 to 20 and their general electronic configuration and learn how to calculate the valency. So here you can see atomic number 1 is hydrogen. The symbol of hydrogen is H. As you know, Z equals to 1. So there is only 1 electron in the first shell. So since hydrogen cannot have valence shell filled with 8 electrons, because this is the very first shell that has only the capacity of 2 electrons. So in the case of hydrogen and helium, the octet rule turns itself into a duplet rule, where the valence shell is supposed to have 2 electrons because the shell cannot accommodate more than 2 electrons. In this case, you can very well see helium has 2 electrons and the shell is complete. Hence, the valency is 0. The valency for helium is 0. That is why all the noble gases have the valency of 0, because their last shell, that is the valence shell, is full. They don't want to make any bonds in order to ensure that their valence shell should be stable. They already have a full valence shell, that is why their valency is 0. But in the case of hydrogen, we can see the valence shell has 1 electron. Hence, the last shell will try to get 1 more electron in order to fill this last shell, that is a valence shell. Hence, you can say the valency for hydrogen is 1, while the valency for helium is 0. Very good job. Now we have already sorted our hydrogen and helium. Let's go forward and figure out a formula to calculate the rest of the valencies. So as you can see here, the valency for all those elements where the valence electrons are 1, 2, 3 and 4. From 1 to 4, if any element has valence electrons from 1 to 4, the last shell, the valence shell, whatever number of electrons that shell has, turns itself into valency. Let's take a look. What does it mean? If you look here, lithium has atomic number of 3, 2, 1. So the valence shell has 1 electron, and we just said from 1 to 4, valence electron is equal to valency. So 1 means the valency of 1. For beryllium, it means the valency of 2. For boron, the valency of 3. And for carbon, the valency of 4. The first rule states that if any atom has the valence electrons from 1 to 4, those number of electrons turns themselves into valency. Okay, let's get started to the next concept. So, for all the elements that have atomic number or the valence electrons more than 4, we just said from 1 to 4, the number of valence electrons turn themselves into valency. But for more than 4, greater than 4, that is 5, 6, 7 and 8. The rule is very simple. The rule says 8 minus valence electrons. Let's just take a look. What does it mean? As you can see, for nitrogen, the K shell has 2 electrons. The L has the 5 electrons. 5, the rule was 8 minus valence electrons, that is 3. For oxygen, 2 and 6, what does the rule says? 8 minus valence electrons, that is 2. Fluorine, 7, rule says 8 minus 7 equals to 1. Lovely rule once again, 8 minus 8 is equal to 0 for neon. We all know that neon is a noble gas. Neon is a noble gas that states that neon does not want to make bonds with anyone just in order to make bonds or to fulfill its shells. So neon is stable the way it is, hence the valency is 0. Sodium 281, again the same rule, from 1 to 4. The valence electron turns itself into valency. Magnesium 2, aluminium 3, silicon is equal to 4. After 4, what is it? 8 minus 5 equals to 3. 8 minus 6 equals to 2. 8 minus 7 equals to 1. 8 minus 8 equals to 0. 1 as it is, 2 as it is. So the very simple thing we need to understand here is, if the valence electrons are from 1 to 4, then the valency is the number of valence electrons. But if the valence electrons are more than 4, that is 5, 6, 7, 8, hence the rule is 8 minus valence electrons. In this video, I will repeat once again, we tried to understand what is a valence electron, what is the valence shell, what does valency mean, and how we can calculate the valency from all the elements from 1 to 20. I hope you like my video, and please do not forget to subscribe to my channel. Thank you for watching.